Hi, my name is Su Zhenwei. My matrix number is 206085.
My name is Li Jiaxuan. My matrix number is 205741.
My name is Li Jiseng. My matrix number is 205754.
Li Pangzhang, and my matrix number is 205851.
My name is Sarah Edna. My matrix number is 207805.
So for the first task, Kelly will present.
Yeah. The first task question is about arithmetic sequence. The questions given the arithmetic sequence, and it gives us the formula, and we need to find the sum of arithmetic series denoted by Sn. So the solution is, I do it like Sn is equal to A1 until summation of A1 until An. The A1 is the first term, and I use the formula as the question given. Then I substitute the n terms into it. Then we'll get this A1 is equal to Sn is equal to A1 plus A1 plus D plus A1 plus 2D, and then until the A1 plus bracket n minus 1 multiplied by D. Then I do another Sn, which is the same but in reverse sequence. So when I sum up the 2Sn, I will get 2Sn equal to this one. Each will be 2A1 plus bracket n minus 1 multiplied by D. Actually, it is the same for all. So actually, it is n terms of 2A1 plus bracket n minus 1 multiplied by D. So I move the multiply 2 to the back, become divide by 2. So my answer is Sn is equal to n divided by 2, and then multiply 2A1 plus bracket n minus 1 multiplied by D. Okay.
Okay, thank you, Kelly. So for the next question, Jiseng will present.
Okay. Task 2 is to create a table which is convert from a plain text to ciphertext. So it's given that A1 equals to B2 and A1, A equals to 1, B equals to 2, C equals to 3, and the last one Z equals to 26. So to find the ciphertext, we use the formula, which is Sn, the sum of the series, to find the ciphertext value. And so with the ciphertext value, we can refer the ciphertext value in ASCII table. Okay, next. First, to find the plain text value for the rest of the alphabets, we let A1 equals to 1, A2 equals to 2, A3 equals to 3. So we find the difference between the A2 and the A1. And equals to 1, A3 minus A2 equals to 3 minus 2 equals to 1. That means A2 equals minus A1 and A3 equals to A3 minus A2 is the same and is the common difference D, which means this sequence is an arithmetic progression, which we will plus 1 plus 1 plus 1 for the next to find the next plain text value for the alphabets. So here is the formula to find the next alphabet plain text value. Okay, next. So for ciphertext value, we use the formula Sn, which is the formula for the sum of the series to find the ciphertext value for the respective alphabet lah. For example, A, we sub A1 equals 1, D equals 14, N equals 3 into the formula, then we get the ciphertext value for A, which is 45. The same as B and C. So alternatively, we also can let this ciphertext value to be this sequence, 45, 48, 51, and 120. 120 is the ciphertext value for the last term, which is the last alphabet is Z. Okay. So we let A1 equals 45, A2 equals 48, and A3 equals 58, 51. Then we find the difference between them. A2 minus A1 equals to 5, A3 minus A2 equals to 3. So since A2 minus A1 equals to A3 minus A2, then the common difference is D, and which is equals to 3. So it's also a arithmetic progression. Then that means we can keep on plus 3, plus 3, plus 3 to find the next ciphertext value. Okay. So after we find all the ciphertext value, here we can complete the table. So here's the table. The plain text, the plain text from A to Z, and the plain text value and ciphertext value. Then the last column is the ciphertext, which is I refer to the ASCII table. Yeah, here is a link where I refer. Okay. Next. Okay. The next question is, by using the completed table, encrypt the text below, which is mathematics is fun. So by referring to the completed table, then it shows that, for example, M, the value of plain text is 13, then we use the formula, which is sum of the series is 81, then the ciphertext value is Q. So the rest is the same. Go back there. Yeah, we use the same formula to find the ciphertext for others. Okay, so here is the encrypted text, which is ciphertext text. Okay, that's it for me. Thank you.
Okay, thank you, Jiseng. Well, for task 3, Dina will present for our group.
Okay. Hello. So for task 3, the question asks us to build a description function. So based on task 1 just now, we already derived the equation so we can get the formula for the arithmetic series. So to build description function, we need to arrange the variables so that we can get A as the subject, because to decrypt, we want to know the plain text value. So now, after arrange all the variables, we get A as subject, so we can find the plain text value, and this is the decryption function. Okay, next. So from the function, we can look at the code, and then we will substitute what we can substitute. So here we have Sn. Sn is basically the ciphertext value. So just now the question mark, the ciphertext value is 63. So we substitute, and then the plain text value will get 7. So when we get all the plain text value, when we want to decrypt the code, we can use the numbers that we get just now, and then we replace it. So we have here 7, 15, 15, 4, and then we write all the plain text value that we get. So when we decrypt it, we will get good job, you did it. So next. So here we have already made a table So it's easier to see like how we decrypt the code. So here we can see that from the ciphertext value, we get the plain text value, and then we get the plain text in the end, which is good job, you did it. So that's all from me.
Okay, thank you. For task 4, I will present for our group. So for task 4, the sequence is given. So find the sum of geometric sequence denoted by Sn. So there is two type of two situation for Sn. One is when r is smaller than 1, while the other one is for r when r bigger than 1. So we do the first one first. When r smaller than 1, okay, we let Sn, this one, the a is the first term, ar second term, and so on until the n term, ar power of n minus 1. So from that we get Sn, and then we multiply r into Sn. So the first term will become ar, the second term will become ar squared, and so on until the last term is ar with power of n. And now for the next step, we take the first equation minus second equation. So before we minus, we can cancel out the same term. That means terms with the same value for the both of the equation. So Sn have ar, and r multiplied by Sn also have ar, so we can cancel. So cancel until at last Sn only left with a, and r multiplied by Sn only left with a power a times r power n. So we take Sn to minus r multiplied by Sn equals to a minus ar power n. And now we factorize the Sn at the left side to become Sn times 1 minus r. And the right side, we factorize the a. So at the right side is a times 1 minus r power n. So now we take the bracket 1 minus r, we move to the right side. So we get Sn at the left side. So at last we will get the Sn is a times 1 minus r power n divided by 1 minus r. So this is for when r smaller than 1. While the next one is for r bigger than 1. The equation is the same, which is we let Sn and the r multiplied by Sn. So this time we take the equation 3 to minus equation 4. With the same process, we just cancel out the same terms for the value of the terms. And at the left side is r multiplied by Sn minus Sn, and left side is r multiplied by Sn minus Sn, while for the right side is ar power n minus a. So we just factorize the Sn and the a, and the r minus 1 we can move to the right side so that the left side becomes Sn. So this is for r bigger than 1. So at last we get these two formulas for r smaller than 1 and r bigger than 1. That's all from me. Thank you. While for task 5 and task 6, Jiaxuan will present for our group.
So for task 5, a sum of money is deposited into a bank account at the end of each month for 5 years. The account earns a money interest rate of 1.75%. So the question asks us to find the compounding factor. Next. So we can use the formula for compounding factor, which is compounding factor equals to bracket 1 plus interest rate bracket power period of time. And the period of time given in this question is 5 years, which is also 60 months, and the money interest rate is 1.75%. So we just put the information to the formula. So you can get 1 plus 1.75 divided by 100 because this is 1.75%, so we need to divide 100 and power 60. So we can get our compounding factor, which is 2.832. Okay, next. So for task 6, suppose that a 315 ringgit deposit is made at the end of each month in a superannuation fund that earn an interest of 14.4% compounded monthly, and use the formula obtained in task 4, find the money interest rate, compounding factor, and also the final amount after 25 years. Okay, so next. So for task 6A, we need to find the money interest rate. And the annual interest rate is given in the question, which is 14.4%, which is also 0.144. So if you want to get the money interest rate, you just divide 0.144 by 12. So you can get 0.012. So for 6B, we need to find the compounding factor. So we also use the same formula from task 5, which is compounding factor equals to bracket 1 plus interest rate bracket power period of time. And the money interest rate, we use the answer we find in 6A, which is 0.012. And the period of time we want to find 1 year, so which is 12 months. And then we put the information to the formula. R equals to 1 plus 0.012 power 12. And then we can finally get 1.1539 as our compounding factor. So for task 6C, you need to find the final amount in the account after 25 years. So we use the formula we obtained from task 4, which is Sn equals to A, which is the first deposit, and R power compounding factor power the period of time minus 1 over compounding factor minus 1. So our first deposit is 350 ringgit, and our compounding factor is 1.012. And the period of time we need to find is 25 years, which is also 300 months. So we put the information to our formula and get 350 times 1 plus 0.012 power 300 minus 1 over 1 plus 0.012 minus 1. And then we can finally get our final amount, which is 1,015,651 and 10 cents. So that's all for task 6C.
Okay, thank you. I think that's all for our group presentation. Thank you every member for your participation. Thank you.
Thank you.